Welcome to the final video in this series. In this video, I'm going to be deriving a very long algorithm in this move set to flip a single dedge on the 4x4 cube. And I would say that this is technically the hardest move set of 2gen for the 4x4 to deal with, as you probably can imagine. It's also quite fun. And the algorithm I find is pretty simple to understand, but quite long. I spent about 3 hours on this in the process of making this video series, but I don't want to invest any more time in it unless I'm given some incentive for some reason or another. Ben currently hasn't found any single dedge flip algorithms, at least he hasn't posted any on his website with ksolve++. So this may be the first single dedge flip algorithm in this specific 2gen moveset. Even if it is, doesn't really matter. I'm sure he'll find one eventually that's the optimal solution with his ksolve++ program. He may have already even found one, but just hasn't put on his website yet. You see, if we go here, this is Ben's website. Yeah, this will be it because this is in sign notation. This is actually equivalent to a wide turn of R, and this is a triple layer turn of U. Yeah, right now he doesn't have anything, but he says it's at least 44 moves. I believe him. Anyway, I'm going to take the previous algorithm that was the key component for the previous type, and I'm just going to modify it. The obvious modification, what do you think it is? I'm going to replace all U's with 3DW. And again, I'm using 3DW instead of 3UW because I'm more comfortable with it, but obviously this can be rotated to become 3UW. And this is what happens when we apply that to the cube. Just happened to work out. Very nice. So we dealt with the corners just like we did with that other move set. But now from this point it's very quick to go from this to a super cube safe single dedge flip algorithm. It means it doesn't affect anything but switching two wings on a 4x4 super cube. So I guess I'll label this type 5 because it technically is, and I'll say 3UW. Even though we're using 3DW instead of 3UW, I'm going to write that. First off, I'm going to take this and I'm going to put this over here because we just need to derive one separate algorithm. Guess what that is? Well, first of all, I realized by repeating this particular move sequence 6 times, then I got this, which is almost equivalent to something that we may know, and that is if I make a commutator with this where I let that equal x in our commutator xy, and then I use 3dw prime as y, then this is equivalent to E2, the move E2. So I'll write E2 equals, to keep that as a tool in our tool chest. So I actually, this is a sub-step to make this, maybe you guessed it, PLL parity. And this may not be the shortest PLL parity, but this is the one I came up with in that 3-hour time period. So I'm going to use it. Next is, well, PLL parity. Instead of doing RW2, 3W2, RW2, 3W2, RW2, I did 3W2 and then it gave me this, where I guess it really makes no difference. I could put it here. I guess it really makes no difference. But I conjugate it like this because of the next step. So I'll leave it like that. So this is almost PLL parity as we knew it from the previous 2gen moveset type, except for a D2 turn. And as a matter of fact, this is pretty much the end of it. If I omit this D2, then I'm an E2 move away from being from PLL parity, and that's where the E2 comes in. So I just combine these two, and then I have PLL parity in the right half of the cube, and that's all there was to it. So I'm going to put this aside. I'm going to call this PLL parity. And now I'm going to grab this again. And I'm going to look at the cycle types. This is going to be based on repetition, obviously. If I switch this dedge with this one, I'm tempted to anyway when I see it, using PLL parity. Sort of like what I did with that previous 2gen move set. If I just grab PLL parity that I just found, if I do the setup move 3dw prime, then PLL parity, and then 3dw, we can observe that real quick on a cube separate. Oh, it's the other way around. I get dyslexic sometimes. Then I have PLO parity in the front to switch the two front edges in E as I need to here. And when I do, then that will put that in place. And, well, this 2 cycle here is that 2 cycle of 9 and 13. And then we have 3 cycles. And then here's a 5 cycle, 3 cycle, 3 cycle, and then 2 cycles. If I repeat this 15 times then, because I want to get rid of both the 5 cycle and the 3 cycle, I get a 2 cycle of X centers and a 2 cycle of the wing edges. But to conjugate this, I couldn't conjugate this. No matter what I did or any shifts, I couldn't conjugate it to be a single dedge flip that didn't discolor any centers. This is pretty much what that was. However, let's just go back to this idea. Let's not throw it out yet. With just a little bit of experimentation and having an open mind. Go back here and I'm going to undo that conjugate. And I'm going to make PLO parity so it doesn't discolor any centers. In other words, I want the centers to be affected to be in one face, not in 2 opposite faces like it is right now. If I do RW prime and then RW, it gets them like this. And instead of, I can't do U2 in this moveset, but I can do 3D W2. And then now I just do RW2. That gets them in D. I need to move this here now. How do I do that? Well, might be a little bit redundant because I just did one setup move, but I put that in front. Maybe is that the way I did it? Let's see. Yeah, I think so, because now I can do a 3D W2 and undo that. And I need to now move this one here. That will be with the RW setup. RW, not RW2. I'm going to fix that. And now I just do, to get into the front, I just do 3D W2 and undo that. Now, I have PLO parity here. All the centers that are affected by this PLO parity version are nowhere else on the cube except for in face F. I grab the piece, which I started with, to switch those two because, again, this dedge is here. I'm tempted to put it here. Even though it's going to put it flipped incorrectly, that's okay, because we want a 2 cycle to be one of the cycles in our cycle type for wing edges, so that when we repeat the sequence an odd number of times, ideally, that 2 cycle will be the only 2 cycle that remains, ideally. When I do that, combine these two together, and I look at the cycle type, it's very, very small. I have, wow, look at this, 2 odd cycles, and they happen to be equal. Fantastic. And they're very small. Fantastic. So 3 things in our favor there. So if I multiply by 3, those 3 cycles go away. However, I have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 cycle of X centers. So if I multiply this by 15, that will be a multiple of 3 to get rid of those, and it also gets rid of all the X centers as well. And we're left with just a 2 cycle of wing edges. And that's really all I have to say about this, except for, even though it's 840 moves, I didn't cancel this, but I just go to Notepad++ and I replace 3D with D, and because my program does not handle repeats, I'm just going to repeat it, and I'll run it through my program. So it says this is a 38 move sequence. I'm going to replace the DW with 3DW. So D with 3D. I'm going to paste it here in place of that. The true number is 570. And of course, lastly, since this is 3DW2 and RW, I can do an RW move to move it in the top or bottom, whatever I prefer. And you can convert to UW and you will still be able to get a dedge flip in the top, in any position in the top you want. So I do RW and then RW prime. And then I do 3DW and then 3DW prime, for example, to get into the front. And there you go. And that's pretty much all I'm going to do with this moveset. This is similar to how I handled the lowercase r uw moveset of 2gen, but clearly it's much longer, and the way I found this was I had to deal with the corners just like I did with the previous 2gen moveset with RW and capital U. I used the same algorithm. I kind of cheated a little bit, and I got lucky with that specific form of PLL parity that made it a perfect repetition setup. If that's what it's called, I'm not sure. But that's it. I hope you've enjoyed this tutorial, and thanks for watching.